Acidity of terminal alkynes. Alkynes can be classified as internal or terminal, depending upon the substitution that they have. A terminal alkyne has a hydrogen that's connected to the sp carbon, whereas internal alkyne has a group that is substituted for that hydrogen. It could be an alkyl group or any other group, right? So now this hydrogen that is attached to the sp carbon is going to be acidic, and that is going to make a big difference in their reactivity. Let's go take a look into some of these compounds and compare their relative acid strengths. We have HF and H2. Between these two, definitely HF is the strongest acid because we know that fluorine is more electronegative than oxygen. And then if we compare between ethyne, ethylene, and ethane, we can definitely say that the acetylene molecule is more acidic because it is connected to an sp carbon, right? Sp carbon is more electronegative than the sp2 carbon and sp3 carbon, and therefore that is the reason why this is more acidic. Now we wanted to see what kind of bases we have to use in order to abstract this hydrogen so it can create the acetylene ion. Let's say that we use hydroxide ion. So if hydroxide ion is used as a base here, then if it's going to be abstracting that hydrogen, these electrons will be shifted on here and it's going to create as the acetylide ion. Now let's circle the acids on both the sides. Acetylide ion here, and we have the conjugate acid, which is water. So let's compare the pK value here. So this has a pK value of 25 and this has a pK value of 15. So between these two, we can obviously say that this is the weaker acid and the reaction will go in the backward direction, right? So which means we'll not be able to form enough of the acetylide ion, or in other words, not all of the acetylene molecule is converted into acetylide ion. So definitely hydroxide ion cannot be used as a base here to deprotonate this hydrogen, this terminal hydrogen. So if it's not hydroxide ion, what other bases can be used to deprotonate it? Let's go take a look into NaNH2. NH2 minus is definitely a strong base than OH minus, and we could clearly see this from here. So let's say that we are going to use NH2 minus. So that's going to go grab this hydrogen and it's going to push those electrons onto carbon, thereby creating the acetylene ion. Now let's identify the acids on both the sides. So we have acetylene and we have ammonia. Let's compare the pK values here. So this has a pK value of 36 and this has a pK value of 25. And the reaction will always go in the direction where the weak acid is present. Now the weak acid is actually present on the right side, and therefore now the reaction is actually going to go in the forward direction. So which means we can definitely use NH2 minus as a base to abstract this terminal hydrogen so we can get the acetylide ion. So if you ever wanted to remove hydrogen from acetylene molecule, then we have to use a stronger base. OH minus cannot be used as a base to abstract this hydrogen. Now what are we going to do with this acetylide ion? Acetylide ion is going to act as a nucleophile. Let's say that you have an alkyl halide. So here is an alkyl halide, and we know that in an alkyl halide, the carbon-Br bond is polar, right? Because of the electronegativity of bromine. So there is a partial negative charge and this carbon is going to have a partial positive charge. And because this carbon is electron deficient, right, the nucleophile is going to make this acetylide ion is going to act as a nucleophile onto this electron deficient carbon, and it's going to thrust those electrons onto bromine. In turn, what you see here is in place of where Br is present, okay, you're going to have this group right here. Okay, so we are able to see that these are the two carbons from the acetylide ion. And we are able to form a new carbon-carbon single bond. In organic chemistry, anytime you have formation of new carbon-carbon single bond, that's a very significant reaction because that's one way to build the molecule. Now, depending upon the number of carbons that you needed, you can choose the alkyl halide. So let's say that I need 5 carbons here, then you can take 1 bromopentane. And in this way, you can tailor the number of carbons in the molecule.